Alright, this is your help video for quiz 4.04. The first one says, what is the area of the rhombus? And it kind of extends the picture here for you because there's another way to find area, but I think this method is a lot easier, and this is the method that I put on your foldable note. What you can do is you can just find the two diagonals. And the diagonal just is when you extend, when you connect opposite vertices. And thankfully these follow the grid, so we can just count them. So this one's 4 units long. This one is 8 units long. And so we can go straight to our area formula. 1/2 of diagonal 1 times diagonal 2. 4 times 8 is 32. Half of 32 is 16. So this would be 16 units squared. Okay, the next question, it gives you all these vertices, but it doesn't give you the graph. And I am so super visual that I have to graph things. So I pulled out some scratch paper and I went ahead and graphed this for us. And the reason the graph is really helpful, for area of a parallelogram, it's base times height, just like it is in a rectangle. But in a rectangle, we know that all the angles are 90 degrees. So it doesn't matter which side we let be the base and which side we let be the height. But in a parallelogram, it does matter because height has to be perpendicular to the base. In any figure, whether you're talking about a rectangle, a triangle, a parallelogram, any figure, the height has to be perpendicular. I think I said parallel, but I meant perpendicular to the base. So what I'm going to do is I'm going to let this side be the base because it follows the grid and it's nice and easy to count. So I can go ahead and count those units. Let's see, from -2 to -20, that's 18 units long. But this side cannot be the height, and that's a mistake that a lot of students make. That side is not the height because it is not perpendicular to the base. You actually have to draw in the height here. The height's not included in the picture yet. You want to start at one of the sides of the base and you want to draw a line perpendicular to it. So this red line would actually be my height. And then I can count that using the grids. And that's 5 units long. So then to find the area, I would just do the base times the height. And I'd go to my calculator and type that in. 18 times 5 is 90. So my area is 90 units squared. Okay, so here's this one. It says, what is the area of the trapezoid? And it does give us a picture this time, which is awesome. So you can check your foldable note for the formula. It's 1/2 of A plus B times H. Okay, now remember, B still stands for base and H still stands for height. And just like in any other figure, the height has to be perpendicular to the base. So it doesn't matter which side we make the base as long as the height is perpendicular to it. And if you notice, we already have a 90-degree angle right here. So I'm going to make this one the base and this one the height. So I'm going to label this as base, this one's height, and then this would just be side A. And unfortunately, you can't count the grid on any of these because they don't follow the grid. So you either have to use Pythagorean theorem or the distance formula. I'm going to go ahead and do Pythagorean theorem. I'm a pretty big fan of that one. So I'm going to draw a right triangle. That side length is 3, this side length is 4. So to find the height, I would do the square root of 3 squared plus 4 squared. 9 plus 16 is 25. The square root of 25 is 5. So now I know the height is 5. Okay, then I need to find the distance of A. So I'm going to go ahead and draw my right triangle again. That side's 3, this side is 4. Hey, I noticed that this is the same triangle. Anytime you have side lengths 3 and 4, you know the hypotenuse is going to be 5. Now you could go over here and you could plug it in. Again, that's fine if you want to go ahead and plug it in if you don't recognize that. But you would get the same answer. Alright, and then for the base, I'll go ahead and show you distance formula so that you can see one of each and pick your favorite. So for the distance formula, you need to label your endpoints as x1, y1 and x2, y2. And it doesn't matter which one you choose as the first or the second. What did I put there? x1, y1, x2, y2. Okay. And then plug it into your distance formula, which says x2 minus x1 squared plus y2 minus y1 squared. And let's see, if we do this, 7 minus 1 is 6. 6 squared is 36. This is negative 8 squared, which is 64. That's the square root of 100, which equals 10. So the base is 10 units long. And then we're just going to plug it into our formula. So area equals 1/2 of the quantity A plus B, so 5 plus 10 times the height, which is 5. So let's see, 5 plus 10 is 15. Half of 15 is 7.5. And 7.5 times 5 is 37.5. You could type all that in your calculator just in one step if you didn't want to use your brain like that. But the area is 37.5 units squared. All right, this one says each small square on the grid is 1 feet squared. Which estimate best describes the area of the figure? So what we're going to do is we're just going to go through and we're going to count square units. And to start off with, I'm only going to count full squares. I'll go back and count the half squares in a little bit. Now keep in mind you wouldn't have to write this in here. You just have to count. You're just estimating. So you would just go through and you'd be counting these. This is a really great test-taking strategy. Anytime it's multiple choice and you can't quite remember how to use the formula correctly, you can always count square units for area. Okay, so I've counted the full squares, and now I'm going to go back and put 2 squares together. I'm going to put those 2 together and call that 36. I'm going to put those 2 and call them 37. I'm just putting together some pieces just to get an estimate. 38. Maybe I'll put those 2 together and make that 39. 40. 41. So I left off a little one there. That's okay. 42. 43. 44. Y'all, this is totally just an estimate. 45. Let's make that 46. Okay. So my estimate came back as 46. You know, it's not exactly perfect, but it should get you the right answer, right? 46 is the closest to 50. So when you want to estimate the area, you can literally just go in and count square units. Now this one, we're going to use the exact same method, but I hope you notice here that the grid, this is kind of like an evil trick. The grid does not go by 1 each time. Right? Each square is actually a half of a unit. So this is pretty tricky. There's 2 ways you can do it. Either you can count the squares like normal and then divide by 2 at the end, which is what I prefer to do, or you can count by 0.5s each time. I'm just going to count like normal, so I'm just going to go through and count my squares. And again, you don't have to write these in. I'm just writing it in so you get an idea of what I'm doing. I would end up doing all of this mentally. I would just go through and count them in my head to get an estimate. All right, and then now that I've done all the whole ones, I'm going to start putting 2 together. So I'd make that 28. I'll put these 2 together and make it 29. Let's put these together and make it 30, 31. So my estimate is about 31. All right, but keep in mind that each of these grid spaces is only a half. So I'm going to take half of that. All right, and I think you can see, I mean, this is going to give me a decimal. Again, these are estimates. But if I pretended like this was 30 instead of 31 and I did 30 divided by 2, this is approximately, the closest answer would be 15 units. Alright, so be careful when you're estimating. Make sure that the grid is either going by 1 or you know what it's going by. And that's it. Good luck on this quiz, y'all.